Hello everyone, I'm Koyan and today we are going to learn what is exactly gametogenesis. I understand whenever students came across this type of topic, students would run away. You get traumatized by it. Even ex-students that sit for SPM, when they look at this, then yeah, some traumatic memories came back. So you can't run away from it since you are going to sit for SPM. Instead, you have to face it. So today I'm going to guide you and help you out when it comes to understanding this hard topic right here. So the reason why it's hard is because you have to master the concept of mitosis and meiosis. So before I enter gametogenesis, which is the production of sperm, I would like to let you know how mitosis and meiosis would affect the number of chromosomes. So we are not entering it first. I'm going to show you what mitosis and meiosis. So let's take an example. Mitosis. Mitosis right here, let's say we got 4 chromosomes. One, two, three, four. Yeah. So they have already duplicated like basically. And then for mitosis, you got a prophase, metaphase, anaphase, and telophase. So what happens during prophase is just that chromatin condensed into chromosome. And metaphase is where they align in the middle of the equatorial plane. So how do you actually count the number of chromosome? Number of chromosome, you basically count it through the centromere. A lot of students get confused. How do you actually count it? Why sometimes some chromosome look in this way, sometimes look in a butterfly shape. So this is actually sister chromatid. Yeah, it's also a chromosome. And this is a chromosome. Both of them are chromosome, just that this one consists of two sister chromatid. This one consists of one sister chromatid. And then for chromosome, how do you actually count? You actually count through the centromere. When it has one centromere, this one is one centromere, right? So it means it has one chromosome. Same goes to this. It has one centromere right here. Means it has one chromosome. So both of them counted as one chromosome. So I know the drawing I draw for the chromosome is X only lah. This has already undergo the S phase where uh, DNA replication occur. So yeah, basically the chromosome consists of two sister chromatid now in the prophase. So for this right here, yeah, 1, 2, 3, 4. So the number of chromosome right here it is 2n equal to 4, which is a diploid number. Right. Now let's continue. In the metaphase, still 4 chromosomes. Now we are entering the anaphase where they are going to be separated. So it's called away anaphase. So now once they are separated, sorry, not 1, 2, 3, 4. They are separated. Okay, 1, 2, 3, 4. So this anaphase is where the separation of sister chromatids. So why is it separation of sister chromatid? Initially, it looks one chromosome consists of two sister chromatid. Now they're being separated. So now they are separated in this way. That's the reason why they are called separation of sister chromatid. So what it leads to in the telophase and after the mitosis stage is that you ended up leading to 1, 2, 3, 4. 1, 2, 3, 4. But it only consists of each of them only consists of one sister chromatid. But did the number of chromosomes actually change? No, it doesn't change. This one is after cytokinesis because the cytoplasm already divide fully. So yeah, telophase is actually still kind of joined together. They are still joining together, haven't entered cytokinesis. So after this mitosis stage, it will lead to two cells. And two cells right here, let's take a look in each cell. Each cell have four sister chromatid. So this sister chromatid, each of them, 1 chromosome, 2 chromosome, 3 chromosome, 4 chromosome, right? So can you compare the number right here? At first, yeah, 2n equal to 4. And in the end, it's still 2n equal to 4. So the number of chromosome does not change for after mitosis. Number of chromosome does not change. What happens only? It actually happens whereby the sister chromatid gets separated. So this is what happens in the mitosis stage. Number of chromosome do not change. So this is very important point. Number of chromosome is still maintained, means it does not change. So initially it's 4, and at the end it is still 4. Okay, because we count the number of chromosomes through the centromere. So here got 1, 2, 3, 4 centromere, so means that it has 4 chromosomes still. For each cell, we are looking at each cell lah. Okay, I know they produce 2 cells because they are duplicating. So mitosis, the usage, the reason why we have mitosis is basically to replace our damaged cell, repair our tissues, for zygote, yeah, formation of embryo also require mitosis. What about meiosis? Meiosis is basically involved in the production of gamete. So mitosis happens in somatic cell, and then the meiosis is normally involving in the production of gamete. So how do meiosis occur? Meiosis actually got two stages, meiosis 1, meiosis 2. That's when the students get extremely messed up, especially when it comes to number of chromosomes the cell produced. So I am also going to do the same thing. Initially right here, 1, 2, 3, 4. 4 chromosomes. Okay, this is meiosis 1. Meiosis. So meiosis 1 prophase, I know they do those crossing over stuff, but I'm not going to take a look into detail. But basically, they are going to undergo the same thing right here, but no, it's actually not the same thing. It's actually, okay, so sorry for that. They are actually going to pair up together, but in a homologous chromosome. So when they got paired, it's called homologous chromosome. Yeah. So meiosis, this prophase, normally they would do crossing over lah, but I didn't really draw in detail. They are going to do crossing over where they will exchange the DNA segment between non-sister chromatid, because this one sister chromatid. But if you exchange with another party, means it's non-sister chromatid. So exchange DNA segment between non-sister chromatid. That is actually very important when it comes to radiation. That's why you and your siblings don't look alike. Don't look extremely alike. Not 100% alike, right? Because of radiation due to this crossing over. Okay, after metaphase, the homologous, they line up together. So a pair line up, a couple line up. Not compared to mitosis is one, line up singly lah. So after metaphase is the part where they separated. So during anaphase right here, can you see that? Wow, they got separated, right? So the couple got separated. So it is basically separation of homologous chromosome. So it's where the separation homologous chromosome occur. So meiosis 1, it actually focusing on the separation of homologous chromosome. So it ends up in what? It actually ends up in 2 cells, and each of them looks this way. Yeah, end up 2 cells already because they got separated. So this is after meiosis 1. Now let's proceed to meiosis 2. Okay, let's count the number of chromosomes because I'm now trying to emphasize the number of chromosomes. So initially is 2n equal to 4. So have you remember meiosis? The difference between meiosis and mitosis is meiosis, it half the number of chromosomes. Half it means you cut it into half lah, divided by 2 ma. simple math. So right here, can you actually count each cell got how many chromosomes right here? One, we count it through centromere. Don't get messed up by the sister chromatid. We are counting through the centromere. One, two centromere. So means that this one got two chromosomes. This one also got two chromosomes. So let's compare with the initial stage. 4 chromosomes, 2n equal to 4. And after this anaphase, right, each cell become n equal to 2, where they have the number of chromosome. So the effect already come out already. N equal to 2, right? 2 chromosome already ended up. Initially 2n equal to 4. Now the number of chromosome already half already. So after meiosis 1, 2n become n already. Means the number of chromosome half. Now let's continue to meiosis 2. Okay. So during meiosis 2, so both of the cell also undergo at the same time. So meiosis 2 is basically, prophase 2, okay, prophase 2, metaphase 2. So metaphase, they are actually, meiosis is actually quite similar to mitosis because now they are not going to have a homologous chromosome this time. Meiosis 2, they just align it singly lah. And anaphase right here, where they are going to be away from each other. So 1, 2, 1, 2, yeah. Sorry, my drawing. I'm just trying to be quick to discuss the number of chromosomes. So basically, this is the sister chromatid getting separated. So can you focus this part? Anaphase 2, right? It is a separation of sister chromatid. Compared to this anaphase 1, it is a separation of homologous chromosome, means you separate out the copper. Then, but for this one, it is actually quite similar to this mitosis right here, where the sister chromatid gets separated. So, yeah, basically, anaphase 2 is separation of sister chromatid, and what it leads to in the end, it eventually leads to 4 4 cells. Okay, and then let's see what happens to the number of chromosomes right here. Did it get half again? No, it didn't get half again. It still have 2 chromosomes compared to previously after the meiosis 1. It is still n equal to 2. It's just that now it left with the sister chromatid lah. Yeah. So 1, 2. So each cell still maintain this n equal to 2. Right. Okay, so end up it will lead to 4 cells lah. Okay, so what are the difference I'm trying to show you is that after the meiosis 1, where separation of homologous occur in anaphase 1, the number of chromosomes become half already. Yeah. Okay, initially it's 4 chromosomes, now become 2 chromosomes. And now let's proceed to meiosis 2 right here. After meiosis 2, where the separation of sister chromatid occur in anaphase 2, the number of chromosomes is still n equal to 2. Okay, so it's the same number after meiosis 1 and meiosis 2. The number of chromosomes is still the same. Okay, just that when you compare initially 2n equal to 4, yeah, after meiosis 1, they already half it. But after meiosis 2, yeah, is like previously n equal to 2, which is half already lah. They won't half it twice lah, okay? They only half it once. When do they half it? Is after the meiosis 1, especially the anaphase 1 process. So normally non-disjunction occur, right, when you want to explain where the spindle fiber fails to form, you have to focus on the anaphase 1 or the anaphase 2. That's where the number of chromosome gone wrong lah, because they didn't separate well. Eventually, maybe the one of the cell will less 1 chromosome, another cell more 1 chromosome. Then, yeah, imagine this one got extra 1 chromosome. This one, let's say lah, this one is the sperm lah, okay? If this one got extra 1 chromosome, it will and then it fills with the secondary oocyte with a normal number of chromosomes, it will lead to a zygote with a normal number of chromosomes. That's how like genetic disorder or this occur lah. Okay. So, hey, what am I trying to say right here after these 15 minutes of explaining meiosis and mitosis is that mitosis, the number of chromosomes stays the same, right? Meiosis, number of chromosomes, after meiosis 1 already half. Then after meiosis 2 is still maintain the same and equal to 2. Already half lah, basically half from like the previously meiosis 1. So now let's take a look at this spermatogenesis, because a lot of students they just half out it but they don't really understand the number of chromosome story behind it. So spermatogenesis is the production of sperm because gametogenesis got divided to two. One is for a boy, one is for a girl. So yeah, spermatogenesis is for the male one. Okay, first of all is the primordial germ cell. So primordial germ cell actually is in the seminiferous tubule. But don't worry, normally they would ask you where do spermatogenesis takes place. It's actually takes place in the testes. Meanwhile, for oogenesis, it takes place in the ovary. Like if you want to look into more detail, is where inside the testes they got seminiferous tubule. So there got the primordial germ cell lah. Okay, so first of all, primordial germ cell, they will undergo repeated mitosis to form spermatogonium. So repeated mitosis what? Mitosis, your number of chromosomes didn't change, right? 2n is still maintained to 2n right here. Right? Didn't change, didn't have this is just mitosis. Okay? So after repeated mitosis to form spermatogonium, it will have to undergo a growth phase where it will grow and develop to become a primary spermatocyte. So you grow and develop, are you doing meiosis or mitosis? No, right? You just grow only, grow maybe into larger size to become more developed. So it is still 2n right here. Primary spermatocyte, it is still 2n. Now let's focus on this part right here. Primary spermatocyte, it undergo meiosis 1. Remember meiosis 1, after the anaphase 1 where the homologous chromosome gets separated, the number of chromosomes already half. So can you take a look at this? 2n, initially primary spermatocyte, 2n. The meiosis 1, that's straight away n already. Yeah, because the number of chromosomes become half. So let's take a look at this part. If you still cannot relate to it, did I show you just now? So initially, the number of chromosomes is 4, right? 1, 2, 3, 4. You count through the centromere. So after this anaphase 1, okay, where separation of homologous occur, okay, after meiosis 1, basically, can you see? Oh, n equal to 2 already. Half already, ma. 4 divided by 2, half already, ma. So after meiosis 1, number of chromosomes already half. That's the part you have to focus on. After primary spermatocyte undergo meiosis 1, it becomes secondary spermatocyte, which is already half the number of chromosomes right here. 2n become n. So I hope you are clear why it suddenly become n after meiosis 1. Yeah. So after it formed the secondary spermatocyte, because primary becomes secondary, then secondary spermatocyte, because the meiosis is not completed yet, it has to undergo meiosis 2. That's the full meiosis process, right? So secondary spermatocyte, it will undergo meiosis 2 to form spermatid. Did it get half again? No, right? It is still maintaining the number of chromosomes n. Yeah. So basically you can see lah. After meiosis, yeah, the number of chromosomes get half. When it get half, it's basically after meiosis 1, it get half already. So 2n become n. And then after meiosis 2, it still maintain the number of chromosomes. Yeah. And spermatid is just a cell, circular shape, oval shape. It can't swim, so it has to undergo differentiation It has to, differentiate into the head, the tail, got mitochondria. Yeah, so it has to undergo cell differentiation to form a sperm with their own specialized function to swim, right? Yeah, so this is how spermatogenesis work. So let me take you, let me repeat it again. So first of all, it's a primordial germ cell. What they do, they will undergo repeated mitosis to form spermatogonium. After spermatogonium, they are trying to grow and develop. Okay, don't so fast go to the what meiosis yet. After mitosis forming spermatogonium, they have to grow and develop to become primary spermatocyte. Number of chromosomes still 2n, 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 still a diploid number. Okay, now after forming the primary spermatocyte, yeah, I only draw one of it lah. So yeah, this part I didn't draw or else it will become very complicated. So I just focus on one part lah, one of the spermatogonium. Okay, so primary spermatocyte will undergo meiosis one. So this meiosis one is where number of chromosome being half already. So secondary spermatocyte is formed, and now from diploid number of primary spermatocyte become a haploid number. A secondary spermatocyte undergo meiosis 2 to complete the whole meiosis process, right? To become a spermatid. Spermatid, it doesn't look like sperm, right? It has to undergo what? Cell differentiation to become a sperm. That's the reason why our gamete is in a haploid number, because sperm plus your ovum also N to become a diploid zygote, which is 2N. We don't want suddenly the child become 4N. Very scary, right? That's the reason why meiosis, yeah, is involved in the production of the gamete. Okay. Now let's continue to the second one right here, oogenesis. So spermatogenesis is actually not really that complicated. As long as you know the process mitosis, meiosis, after meiosis 1. And normally they would like to trick students when it comes to the number of chromosomes. They will ask it frequently in the objective question lah. They ask you what is the stages, what you form, and what is the number of chromosomes. And a lot of students fall trapped in between the primary, secondary spermatocyte. Okay, so now let's continue to oogenesis, where students struggle the most. So other than oogenesis is the menstrual cycle. Yeah. So let's take a look at oogenesis. So oogenesis is a production of this secondary oocyte. Yeah. Female gamete in the ovary. So I believe you know where is the ovary, right? Okay. So I'm not really, yeah. So basically it occurs in the ovary right here. The drawing is the book lah. Okay, okay. So it basically occurs in the ovary. So yeah, oogenesis. The reason why it's complicated is because it keeps stop and then start and then stop and then start and stop. Okay. So for oogenesis right here, first of all, also start with a primordial germ cell which is in a diploid number 2N. After that, primordial germ cell will undergo repeated mitosis to form oogonium. And oogonium will grow and develop to form a primary spermatocyte. Can you see the familiarity between the spermatogenesis and oogenesis? Primordial germ cell undergo repeated mitosis to form the oogonium. But for spermatogenesis, it's spermatogonium, different name only. And then the oogonium will grow and develop. Same goes as the spermatogonium grow and develop to form the primary spermatocyte, and for female is primary oocyte. Starting from primary oocyte, students pengsan. Why? Okay. This is actually occurring. Okay, this whole thing actually occur in the fetal stage where the fetus is still in the mother's uterus. Kind of scary, right? You already started in the fetal stage. Alright, so this in the fetal stage, the primary oocyte actually starts to undergo meiosis 1. but it punched already. At the prophase one, it punched, it stopped already. So primary oocyte, yeah, it basically undergo meiosis one, but stop at prophase one. It's like you want to start but stop at the prophase one already. Yeah. So at the same time, right, the primary oocyte will get encapsulated with one or more layers of follicular cell to form a primary follicle. So what does this mean? What does primary oocyte, primary follicle, what's the difference? A lot of students get messed up. So primary oocyte is basically, yeah, like a very, yeah, primary oocyte. Okay, so this one is a primary oocyte. So when it get encapsulated with the follicular cell, okay, encapsulated, it will become a primary follicle. So this whole thing right here, including the primary oocyte inside, is called primary follicle. Means that primary follicle is the big one. Inside of primary follicle called primary oocyte. That's the differences between both of them. Okay, so after that, this primary oocyte, yeah, basically after the birth of the child lah, the girl, okay, it actually accumulate millions of at birth. But when it comes to reaching puberty, like 12, 13 years old like that, the number of primary oocyte will actually decrease lah. Yeah. So all these primary oocyte, abundance of them is still dormant in prophase 1. But when it reaches puberty, that's where we all start to experience this menstrual cycle. Yeah, because every menstrual cycle, there will be only one of the primary oocyte. I know a lot of them, only one will complete the meiosis one to form first polar body and a secondary oocyte. Only one. Okay, remember, only one. Okay, it will, yeah, it will undergo meiosis one. It will complete meiosis one. Yeah, meiosis one finally completed at puberty. Yeah, during the menstrual cycle. Every menstrual cycle, one will complete meiosis one to form first polar body and the secondary oocyte. So this secondary oocyte, it will, yeah, basically primary follicle. Yeah, I mean, it also encapsulated with more follicular cells to become a secondary follicle. So also the same thing lah. And the reason how primary follicle grow into secondary follicle is stimulated by the follicle stimulating hormone. It's very direct lah, follicle stimulating. So it stimulates the follicle growth. Yeah, that's the reason why primary follicle it grow into the secondary follicle. Alright, now this continues with this first polar body right here. They very fast lah. They just complete meiosis two to form two second polar body. Yeah. But secondary oocyte, it will undergo meiosis two, but not completed yet. It stops at the metaphase two. Just now is undergo meiosis one, but stop at prophase one. Okay, but this one, secondary oocyte, when you want to undergoing meiosis two, it stops at the metaphase two. So when it stops at the metaphase two, okay, at the same time, the secondary follicle will develop into the Graafian follicle. And this Graafian follicle means it's a larger size of the follicle, more mature, more larger. Okay, so this Graafian follicle, right? Yeah, the growing follicle will actually release estrogen. So the reason why it releases the estrogen is to basically thicken the endometrium and for maturation of follicle. You keep stimulates the follicle until it mature. Okay, I know FSH is stimulates growth of follicle, And then it also stimulates follicle to release estrogen. So this estrogen is stimulates the follicle to grow until it mature. So now it becomes a mature Garfield follicle. So when it finally mature, like the reason why it stops at metaphase 2 is because they are trying to wait for the Garfield follicle to mature to only release the secondary oocyte. So now this mature Garfield follicle time to say bye-bye to the secondary oocyte inside the mature Garfield follicle. So what will actually happen is there will be a hormone, luteinizing hormone, yeah, will stimulate ovulation to occur. What is ovulation? Is actually saying bye-bye to secondary oocyte, where it is a release of the secondary oocyte. Sorry for the oocyte. So when it release the secondary oocyte right here, this Garfield follicle end up don't have the secondary oocyte, right? It will become a corpus luteum. Yeah. Okay. So the secondary oocyte that is now finally released, right? They are waiting for the sperm to come. Okay. So um now it released already. And then yeah, basically in the fallopian tube right there, they are waiting for the fertilization of it. So secondary oocyte, they will only complete meiosis 2 to form the ovum and second polar body. So secondary oocyte, very pattern one lor. If there's no sperm, they will not complete their meiosis 2. Then they will end up die, okay, degenerate. So secondary oocyte be like, why will only complete meiosis 2 if there's a sperm penetrate me? So when the sperm penetrate the secondary oocyte, right, it will form second polar body and the ovum. Okay, it will form second polar. Okay, now I'm trying to say if fertilization occurred, the whole meiosis process occur completely. Yeah. So secondary oocyte complete meiosis 2 when sperm fertilizes it, it will form second polar body and ovum. Then yeah, basically it penetrates after penetrating secondary oocyte, which is the immature secondary oocyte. It will become more mature, which is the ovum long. So the sperm will fertilize with the ovum to form the zygote. So yeah, basically become zygote already. At the same time, the corpus luteum right here, what do they actually do? Okay, they still play its role when fertilization occur. Why? Because you need to prepare for the implantation of embryo, right? So in your uterus, right, you need to maintain the endometrium thickness and reach it with blood vessel. So all these are required for these two hormones, which is estrogen and progesterone, to stimulate it, to maintain the endometrium thickness to prepare for the embryo implantation. So yeah, corpus luteum, if fertilization occur, corpus luteum will still maintain where it will still continue to secrete estrogen and progesterone. Okay, so this is actually what happens if fertilization occur. Basically, the corpus luteum will not degenerate and will continue to secrete estrogen and progesterone to maintain the thickness of endometrium. And meanwhile, secondary oocyte for the sperm fertilize it. So the secondary oocyte can only complete meiosis 2 if fertilization occur, forming second polar body and ovum. And this ovum, yeah, the sperm will fertilize this ovum, which is the matured one, to form a diploid zygote. Now let's take a look. What if there is no fertilization occur? This secondary oocyte be like, hiya, no sperm come. So they unable to complete meiosis 2 this time if no fertilization occur. So if no fertilization occur, secondary oocyte cannot complete meiosis 2. So in the end, useless law, die, degenerate. Yeah, it will degenerate. But At the same time, the corpus luteum realized that, oh, I don't really need to continue secrete estrogen and progesterone since there is no presence of this sperm to fertilize to form the diploid zygote to prepare for embryo implantation. So corpus luteum will just degenerate loss since no fertilization occur. So when it degenerates means it will not stimulate the thickness, the thickening of endometrium. So, because now no estrogen and no progesterone, right? So no estrogen, no progesterone cannot stimulate thickening of endometrium. No stimulation of thickening means it will start to shedding of endometrium. Yeah, so basically leads to a shedding of endometrium. Then the menstrual cycle starts all over again. Okay, so basically this oogenesis, if fertilization occur, what are the products? It will be second polar body, second polar body, second polar body, and only one ovum right here. Yeah, kind of crazy, right? Three second polar body is formed and one ovum formed. Compared to sperm, yeah, so many sperm form, but for oogenesis is different. These three polar body will ended up degenerate, but this ovum will be fertilized to become a diploid zygote. So these three second polar body, basically useless. But if fertilization do not occur, it will only end up second polar body, and secondary oocyte because this secondary oocyte didn't get to undergo complete meiosis 2 process. So they realized no use already. So these three of them degenerate. So second polar body and ovum is not formed lah if no fertilization occurred. So oogenesis is different. It will only complete the whole meiosis process if fertilization takes place. So let's see it once again. So oogenesis is where primordial germ cell, during the fetus stage lah, where we all still are still fetus, okay, inside the mother's womb, okay. The primordial germ cell will undergo repeated mitosis to form oogonia. Number of chromosomes still stays the same lah. Then oogonia will grow and develop to become primary oocyte. So primary oocyte will be encapsulated with the follicular cells to become the primary follicle. Okay, so the primary oocyte actually undergo meiosis 1, but it's dormant at prophase 1 until it starts to reach puberty. So by reaching to puberty, right? Yeah, that's where the menstrual cycle starts lah. Okay, so every menstrual cycle, there will be one primary oocyte will undergo this meiosis 1 completely to form first polar body and secondary oocyte. So first polar body, they continue complete meiosis 2 to form 2 second polar body. But this secondary oocyte, it will basically continue to get encapsulated with layers of follicular cells stimulated by this follicle stimulating hormone to become secondary follicle. It's just more larger version, more developed, more larger. And then, it will still continue to develop into the Graafian follicle. And the Graafian follicle continue to develop into a mature Graafian follicle. So the secondary oocyte right here, it actually stops at the metaphase 2, basically waiting for the maturation of the follicle, Graafian follicle. So when it stops at metaphase 2, it waits until it matures. So when it finally matures, it's time to release of secondary oocyte. So during the release of secondary oocyte, it will actually lead to formation of corpus luteum. because the secondary oocyte from the mature Graafian follicle already left. So this secondary oocyte that is released right now, it will only undergo complete meiosis II process if sperm fertilizes it. Yeah. So if sperm manage to fertilize it, it will form second polar body and ovum. Then yeah, the ovum fuse with the sperm and form a diploid zygote. So when fertilization occurs, the corpus luteum will continue to maintain its role to secrete the estrogen and progesterone, where these two functions to maintain endometrial thickness. While the when meiosis pula, when fertilization do not occur, corpus luteum will just degenerate. When corpus luteum die, it will not secrete estrogen and progesterone anymore. No more estrogen, no more progesterone. It won't stimulate thickening of endometrium. Nothing to stimulate thickening of endometrium. The endometrium, of course, will shed. So, yeah, basically, this is what occurs in it. And yeah, if no fertilization occurs, secondary oocyte will not undergo fertilization, will not complete meiosis II, so it will degenerate in the end. So, yeah. Now let's take a look at the comparison right here. So this is one of the trials paper. Process A, process B. Process A is basically, can you see there's a sperm word? Then yeah, it's basically spermatogenesis. Process B is a oogenesis. So these are all the process right here. It's more a completed version lah. So you can see they undergo mitosis, form spermatogonium or the oogonium, then undergo growth and development to become primary oocyte. Okay, and then primary spermatocyte undergo. Here is this meiosis 1. Yeah, meiosis 1 right here. Yeah, meiosis 1 to form this secondary spermatocyte. So this secondary spermatocyte right here, yeah, it is already half. And secondary spermatocyte undergo meiosis II, form spermatid will differentiate. Okay. Now let's take a look at this oogonium. So oogonium will form to primary oocyte. Grow to become primary oocyte. And primary oocyte, I know that there are a lot of stopping process, but this one is very direct. They straight away say if meiosis 1 occur, because every menstrual cycle, one primary oocyte will undergo complete meiosis 1 to form secondary oocyte and polar body. So polar body will complete meiosis 2 to straight away form the polar bodies. But this secondary oocyte, it will only complete meiosis II if fertilization occur. So it will only complete meiosis II if fertilization occur. So if fertilization occur, yeah, it will form ovum and another polar body. So yeah, the product right here, it looks in this way. So how do you actually compare the process? Both are actually gametogenesis, general term, involve mitosis and meiosis, right? And both also start with a diploid primordial germ cell. Both, what is the function of gametogenesis? Produce a haploid gamete, right? So both also produce haploid gamete. Both also occur in reproductive organ. So what are the differences between them? Yeah, basically you can go and compare it. Spermatogenesis is diploid primordial germ cell undergo repeated mitosis to form diploid spermatogonium. But for this oogenesis is from diploid oogonium, just the differences in the name lah. Then oogonium grow and develop into primary oocyte, but this one is called primary spermatocyte. So these small stuff, small name difference, you can also compare. And then yeah, primary spermatocyte undergoes meiosis 1 to produce 2 haploid secondary spermatocyte. Meanwhile, for this one, it will undergo meiosis 1 to produce 1 haploid secondary oocyte and 1 polar body. Can you see the difference right here? Right here. Yeah. Okay. And then, yeah, you can continue this part. 2 haploid secondary spermatocyte undergo complete meiosis II to form 4 spermatid in the end. And spermatid will undergo differentiation, but For female one, they do not undergo differentiation. They don't need a head or tail or some special features, okay? They're just waiting for sperm to fertilize it. And then, yeah, haploid secondary oocyte undergo meiosis II to form ovum and polar body. And this meiosis process is actually completed before fertilization for this sperm. But for female one, they will only, remember the secondary oocyte, their code is, will only complete meiosis II if sperm fertilizes. I mean penetrates. So yeah, it will only complete meiosis II if sperm penetrates it. And then if sperm manages to penetrate completed meiosis II, yay, it will produce one haploid ovum, three non-functioning polar body. But for spermatogonium, all of the four haploid sperms are functional. And then it will occur continuously after puberty until old age. Then millions of sperms are produced daily, but for female it's only one, unless it's different case lah. If there is formation of this fraternal twins, then maybe two, but we just write it in the most common situation is only one. And then the process occurs continuously after puberty until old age. But for female one, it keeps stop, continue. So it actually begins at fetal but stop until it reaches puberty. Then it will still continue. Then when it stops at last is during menopause. Yeah. So that's all for this oogenesis and spermatogenesis process. I hope you understand. And I'll see you in the next video. Bye bye.